So now we start our work on solving systems of linear equations in two variables. Up till now, our work has been dealing with one single equation in two variables, and we've graphed them. These lines, we've rewrote them in slope-intercept form. We found intercepts, we found the slope, and we've even done applications in which we use these linear equations to solve word problems. But now we're going to have a system of two linear equations grouped together. So that's what a system is. It's when two or more linear equations are grouped together, we call that a system of linear equations. And when we talk about the solution to the system of linear equations, then those will be the values of the variables that make all of the equations in the system true. A solution of a system of two linear equations is going to be represented by an ordered pair xy. So for example, take a look at example number 1 where you have a system of two linear equations. The first equation, equation 1, which is 2x minus 6y equals 0. And then we have equation 2, which is 3x minus 4y equals 5. And in this particular problem, they want us to determine whether the ordered pair is a solution to the system. And so they've given us this ordered pair 3, 1, and we need to see if this ordered pair is one of the solutions that will satisfy this system, which means that we're going to replace. So as you know, the ordered pair 3, 1 means that x is 3 when y is 1. And we're going to replace the x with a 3 and the y with a 1 and see if we get a true statement. And we're going to do that for both equations. So here I'm doing in the first equation, and here I get 6 minus 6, and that does equal 0. So the ordered pair 3, 1 does solve this first equation. It's one of the solutions for the first equation. Now let's substitute the ordered pair in our second equation as well. And now let's see, we have here 9 minus 4, and that does equal 5. So because the ordered pair 3, 1 satisfies both of the equation, makes both of the equations true, then we say that the ordered pair 3, 1 is a solution to the system of two equations. Okay, now in this system, our equation 1 is the equation 2x plus 3y equals 6. And then our second equation is y equals 2/3 x plus 2. You probably recognize the second equation as being a line in slope-intercept form and the first equation as being a line in standard form. And we're going to see if the ordered pair -3, 4 is a solution. I'm just labeling this to remind me that the x is going to be replaced by a -3 while the y gets replaced by a 4. And we're going to see if we get the 6 that's on the right hand side. So here we get -6 plus 12, and that does equal 6. So our ordered pair does satisfy our first equation. Now let's see about the second one. Y is 4, and we need to take 2/3 times -3. I'm going to put it over a 1, and then it's a plus 2. And now here I can reduce these 3's, and I'm going to get 2 times -1, which is -2 plus 2, or 0. Now, 4 does not equal 0, so our ordered pair makes the second equation false. So what that tells me is that this ordered pair -3, 4 is not a solution to the system. Now, in our next videos, we're going to show you 3 methods of solving these systems so that we can find the ordered pairs that make both equations true.